All right, hello. We're going to talk today about the final project. Okay, now the final project is going to sound pretty daunting. It's going to sound pretty hard, but it's not. Okay, so you just need to trust me. Talk to other people who've had the class in the past. There's a lot of points on the line here, and it's designed to give you some good practical knowledge moving forward with the class. Okay, so that being said, let's look and find where is the final project here. I thought I had it in here somewhere. There it is. So you're going to have a final project. You're going to get a data set. Okay, and the data set you're going to take the data set and you are going to take those variables, take that. All right, so like here's a data set, right? You're going to take these numbers and you're going to do certain things to them. You're going to make it so that you come into a meeting, you can present the data at a meeting. So we've got some real practical examples for you for what to do with the data. Okay, so here's the directions. Okay, and we'll tell you a little bit more. You'll be able to see these stuff pretty soon here, but with the directions, you're gonna take your data, okay, and you're gonna convert it into five slides. Okay, is it 5 slides? It is 5 slides. Okay. In one of we talk about this before. We define, we collect, we organize, we visualize, we analyze. Okay, so what I'm going to do for you is I've defined, collected, and organized the data. You're going to visualize it and analyze it. Okay, I'll provide you with a data set. You were able to work in your group. Everybody's going to have a different data set, so the problems are all going to be the same, but there will be different data that you're working with. Okay, so you're going to take these and you're going to organize stuff through an Excel spreadsheet. Okay, and then you're going to put these into a PowerPoint presentation. Okay, I don't remember the exact points, but I want to say like 10-11% of the grade is going to be the Excel project. 10-11% of the grade is going to be the PowerPoint presentation. Okay, so slide one, you're gonna have a first slide, like a header slide. Then slide one is going to be, you're going to construct a frequency distribution using 5 classes. Okay, and you've done this. Well, I'll show you directions here in a second. Okay, what I have here is let's see, I'm going to go right here. Let's go back. Okay, I've got some Excel examples here. Here's a video on how to do a frequency distribution. Okay, so slide one says do a frequency distribution. Here's a video that describes how to do a frequency distribution. Okay, so know that. All right, where did my word sheet go here? Slide 2. You're going to define the population, the sample, define the population, define the sample, and then I want you to display the mean, median, mode, variance, and standard deviation. That's pretty easy. Slide 3. Use additional directions in your tab, but I've given you 3 normal distribution problems, so some probability problems I've given you. Okay, you're going to solve those. Slide 4, you're going to construct a 90% confidence interval for the population mean. And slide 5, you are going to, at the 0.05 level of significance, test the claim, and I will give you a claim. Okay, so right here, this is how you can draw a bell-shaped curve in Excel, or yeah, in PowerPoint. Okay. Yesterday I posted 2 video examples for how to do confidence intervals and how to do hypotheses testing. Now what I did is I've got this. This is an example of a project last year. This is A work. Okay, this person got an A on this project. So here's our first slide. Okay, and I wanted to look the part, right? We don't want to just have a dull slide. This is your presentation. Okay, so this is slide 2. Okay, I would rather have had, what is this, right? This is this is a statistical analysis of the average temperatures. So on slide 2 here, these are temperatures. So this is between 41 degrees and 51.8. This person just put classes. I would rather it say temperature down here, right? So that could fix that up a little bit. Collected data. There's the population. There's the sample. There's the mean, median, mode, standard deviation. They forgot variance. Okay, so I probably took off a point for forgetting variance. Here's our confidence interval, right? I like this. I like that they gave me the confidence interval equation. They gave me the error formula, left endpoint, right endpoint. And then they said, with 90% confidence, you can say the population mean for temperatures at Cincinnati Reds games falls between 76.46 and 81.22 degrees. Okay, probably didn't need 2 decimals, but it's fine. And then here's the last slide. The Reds claim that their average temperature is at least 81 degrees. Okay, so what do we... remember we have to draw at least 81 degrees, so we got to do an HO, an HA. Mu is greater than or equal to 81. Mu is less than 81. That's our claim. Okay, as at least, so it's a left tail test, right? All that stuff we know because we know how to do the problem by hand, but then we know how to do this on the computer as well. Okay. So if I take my data set here, we know how to do all this stuff. Your Excel spreadsheet should look like this. I should have over here, I'm going to put over here, I'm going to have a mean, median, mode, variance, standard deviation, right? And I'm going to do all the formulas, equals, average. The directions will be clear, whether this is a population or a standard deviation, or population or a sample. Okay, I'm looking at, what is this, credit scores? Okay, this is going to equal median. Okay, and then variance. Let's just say we're dealing with population here. Well, you know what? I think in all of these, I made these all samples, so we're going to do sample. Because if I made it population, you wouldn't have a sample to describe. Okay. So we go to, let's do this. The questions asked for a confidence interval, right? confidence interval. Okay, I need my error. I need, let's do this, let's put my mean, let's put my error, and then let's put left endpoint and right endpoint. Let's round these all to 1 decimal. Okay. My mean is going to equal K2. My error, okay, I'm going to go back here to my to this, if we remember this. Okay. I don't think I shut off the camera. I think I've got the camera on this the entire time. Okay, that's fine, I guess. But we're going back to this page right here. And so what's our first question? Is our n greater than or equal to 30? Right? And in this situation, it is. Right? So what we know is, we've got a yes. We've got a yes up here. Do we know our population standard deviation? And in this situation, we know our, we know our sample standard deviation. Okay, so we don't know our population standard deviation, so we are going to use the t-distribution for our confidence interval. So we're going to go back to that, and so now my error, okay, this is going to be equals confidence dot t. Remember, it's going to be here t. Our alpha, I wanted, what did I say, 90%? I think I said 90% confidence, which is an alpha of 0.1. Our standard deviation is going to be K6. Okay. And what is our sample size? I think it's 144, 143. I think it's 143. Okay. Now what I should have in here is I should have done a count as well, and my count equals, or maybe, yikes, make that my n, and that is really equals count this is my total n. So it was 143. So even in my formula then I could have turned around and made that K7. Okay, so there's my error. Okay, my left endpoint is going to equal J9 minus J10, and this is going to equal J9 plus J10. Oh, good grief. That's not good. That's scary. Let's do this. I'm going to change a number here. Oh, that wasn't enough. Whew. I feel better. All right, good. All right. Whew. Much better. All right, so now that is that's in our formula, right? So that's this slide. Where did we go? That's this slide right here, right? There's my confidence interval formula. There's my error. There's my left endpoint. There's my right endpoint. I just did in 30 seconds, not really 30 seconds, but 2 minutes, right? I just did the work for 20% of this project. Now you just got to put it into a picture here. Okay. Next, we're going to do, let's test the claim. let's make the claim that the average credit score, this company claims that the average credit score is at least is less than 700. Okay, they claim the credit score is less than 700. So mu, let's go here to that. Let's go to that. Mu is less than 700. Okay, that's going to be our HA. We're going to have a left, it's still going to be that, it's still going to be a left tail test, or HO is going to be mu is greater than or equal to 700. Okay, now let's go here. Well, let's go back. Let's go back here. Do we know our populations? Is our n greater than or equal to 30? Yes, it is. Do we know our population standard deviation? In this situation, we do not. Okay, so we're back here to using a t distribution. Okay, so I'm going to come here and I'm going to create. Remember, we need to create a dummy variable. I'm going 0, 0, 0. And I'm going to go here to data. And I'm going to go to data analysis. And I'm going to do t-test, to sample, assuming unequal variances. And what is this going to be? My variable 1. Let's get rid of this stuff. I don't know where this stuff. Oh, this must be in there from yesterday's stuff. I want a 0.05 level of significance. Okay, my data 1 is going to be right here. It's going to be all of these. That's my first variable. Whoops. And then my variable 2 is going to be these. My hypothesized mean difference, would we say it was 700? Okay, so we hit OK. And then this is what pops up. Excuse me. Oh boy, we went too high. I got a minus 18 t-stat. All right. So you won't get anything like that. That's going to freak you guys out. You shouldn't have a t-stat number that big. Let's go back in here. Let's go back to data analysis. Let's do a critical value for. Let's do a hypothesized mean difference. Let's call it. Let's call it 680. Let's see what happens when we do 680. I got to come back to this page here. I'm going to go back here. There's my 680. I still get a minus 9. Wow. Alright, let's try it one more time. We're going to call it 662. Alright, we'll just make it ridiculously close this time. Alright, when I do 662, right, I have a one-tail test. It's a left-tail test, so that right here is my critical value, 1.655, okay, for the t-value. That's my critical value. And it's a minus because it's a left-tail test. That falls in the do not reject zone. So this table here gets us all the information that we need for right there. Okay? I will have your names next to your data sets that you're supposed to be using. And look, this is all we're looking for. That's it. Okay? That is that is a work, and there's video examples how to do each one of these slides. Okay, so in 20 minutes, I just showed you how to do the entire project. Okay, you have to still do it in PowerPoint, but that shouldn't take long. Okay, and the due date will be the last Friday of finals week. Okay, all right, thank you.